Alright, so this is your video for 4-5. It is continuing on with those congruent shortcuts. Last lesson we learned about side, side, and side angle side, and today we're going to learn 3 more. So your vocabulary grid, you have included side. We learned included angle last time, and it was the angle stuck between the 2 sides we were talking about. This is going to be the exact opposite of that. Included side is the side that's stuck between the 2 angles that you're talking about. So it's the same kind of concept, only reversed. You can also tell this one without the picture, because if you're talking about angle P and angle Q, then the included side is going to be side PQ. So these are easy to pick out, especially even if you don't have a picture. Okay, that leads us to the angle side angle congruent. So it's kind of the exact opposite of side angle side. It's the other way. So it says if we have 2 angles and the included side from one triangle congruent to 2 angles and the included side from the other, then those are the only 3 pieces of information we need to say the triangles are congruent. So angle, side, angle. Remember, the order in which it's written tells us everything we need to know. Angle, side, angle. So that's the order we have to look for. Okay, so this one's not a proof. It's just saying look and see if you can use angle, side, angle. It doesn't say see if the triangles are congruent. It says see if you can use angle, side, angle. So on this one, they gave us 2 angles. We have this side that we know by the reflexive property is going to share, but what you need to see is this in the right order? Is it angle, side, angle? And it is not, because it's not the included side I have the outside. We'll learn later in this lesson that this actually is okay to have it in this order, but that's not what they asked. They asked, is it angle, side, angle? So you would say no, the included side is not necessarily congruent. They gave us the non-included side and I wanted the included side. Okay, B, same story. Determine if you can do that. All they gave us in this picture was that KL is parallel to NM, and we have been talking about for the last several days that that is leading us to alternate interior right here. So that's good. And then we know NN, how about NL is congruent to itself by the reflexive, but that's not enough to do angle, side, angle. If I wanted to, I would need this other angles over here, and this is a concept that we talked about a little bit in chapter 3, and it's kind of sticky. It looks like if these are, then these have to be, but it's not necessarily the case. If you're looking at these as alternate interior angles, then this is your parallel lines cut by your transversal. And do we know anything about these lines, KN and LM? No, we don't know that they're parallel. They might be, but they might not be. And if they're not, then these alternate interior angles are not congruent. So I have 2 angles for sure, and I have one set of angles for sure, and I have one side, but I don't know about the other side, so I can't say it. So that's what I'm going to say. It is not given that KN is parallel to LM, so I don't have another set of angles to use for angle, side, angle. And there's several ways that you can say that. Just make sure that you're being clear. When you write an explanation, you want to reread it and pretend like it's somebody who doesn't really know geometry, that you're explaining it to them kind of in simpler terms, that you're being thorough. In other words, sometimes I know what y'all are saying, but what you're saying is kind of vague and using they and it and that kind of stuff. So use specific letters and stuff if you can. Okay. You can use the third angles theorem. That one's kind of important if you haven't noticed already, to prove another congruence relationship that is based on angle, side, angle. Okay, and that one is angle, angle, side, and that's what I alluded to in the first and the last example over there, is that angle, angle, side does work, but it only works because of angle, side angle, and we're going to see that in this proof right here. So we're proving the angle side theorem here. So we're not going to use angle side, but that's what we're proving why it's true. So we are given that G is congruent to K and J is congruent to M, and also that HJ is congruent to LM. So we have them separated. These two are here as a given. And then we can see that there's another given down here. So let's just go ahead and put that in while we're talking about it. Okay, so if these two angles are congruent, your second step is that angle H is congruent to angle L. And we know, surely we know by now, if two angles are congruent in one triangle are congruent to two angles in another, the third angles have to be congruent by third angles theorem. Now when I do that, I can see that these triangles must be congruent because I have my angle side angle that I learned about a second ago. So what that means is that I don't have to go through this step all the time because it's always going to work that way. If they give me two angles and the non-included side, I could always go through and say, okay, third angle is angle side angle. But I don't need to do that anymore. If I get this same setup where I have two angles and the non-included side, from now on I can just jump automatically and say, oh, that's angle side. And that's good enough for me. I don't have to go through these steps every single time. Angle side will work for me. Okay. Alright, so we're going to use angle side on this one to prove that it's congruent. I've already got my stuff marked here. Angle X is congruent to angle V. Angle YZW is congruent to angle YWZ. And XY is congruent to VY. So all of these, this is only a 4-step proof, so all of these givens are going to go in the same step. And I also already know that my ultimate goal is to prove that these triangles are congruent. Especially when they're using V, X, Y, W. Be very careful you're copying this exactly. These letters are easy to get confused. Okay, so they gave me these interior angles here on this triangle that I don't care about. So what I need to be able to do is relate these interior angles to the outside, to the triangles that I do care about. So you're going to talk about what is the relationship between this inside angle and his partner outside, between this inside angle and his partner outside. So we know from chapter 1 that these are a linear pair and that linear pairs are supplementary. So that's what I'm going to put for step 2. Angle XZY and angle YZW are supplementary. Same thing on the other side. Angle YWV and angle YWZ are supplementary, and that is the linear pair theorem. Now this is kind of 2 steps in one, and this is a proof we didn't use a theorem we didn't use very often, but it's very important. I can consider these 2 angles on the inside the exact same angle because they are congruent. So if I want to call this one angle 1, I can also call this one angle 1 because they're the same angles. So I can call this angle out here, let's call them angle 2, and this one over here angle 3. So if angle 2 is supplementary to 1 and angle 3 is supplementary to 1, then that means angle 2 and angle 3 are congruent. So angle YZX is congruent to angle YWV. Okay, this we learned in chapter 2, I think, and it is called the congruent supplements theorem. And this is the picture I always draw on the board when we forget congruent supplements. And I say, if this angle is 80 and this one is 100, then they are supplementary. If this angle is also supplementary to this guy over here on the right, he's not changing from 100, so that must mean this guy over here has to be 80 as well. So they have to be supplementary as well. So what that says is if one angle is supplements with two different angles, then these two different angles have no choice but to be congruent. And that's what we have here. It's only just a little different because we've got two sets going on, so that's a little confusing. But if you look at it in terms of numbers, 2 is congruent to 1 and 3 is congruent to 1. So 2 supplementary with 1 and 3 supplementary with 1. So 2 and 3 have to be congruent. There's no other choice. So that is the congruent supplements theorem. It comes back about once a chapter, just enough for you to forget it. Now that we have all that, then we can say the triangles we care about are congruent by angle, angle, side. Okay, angle, angle, side, angle, angle, side. Okay, last congruence theorem is called the hypotenuse leg. And you know from previous years that you only use the term hypotenuse when you have a right triangle. So this one only works if you have a right triangle. And what it says is if the hypotenuse and the leg from a right triangle are congruent to the hypotenuse and the leg from another right triangle, then the triangles are congruent. Okay, so it only has 2 things you have to worry about instead of 3, but you also have to worry that it's a right angle to start with. If I have this same thing with obtuse angles here, like this and this, that's not enough information. And even if I know that these obtuse angles are congruent, we don't have one that is angle side side. That's not one we have, or side side angle. So this doesn't work. It only works if you are sure that these are right triangles. So while you only have to check on 2 pieces, the hypotenuse and the leg, that's a little misleading because you have to check, is it a right triangle? And then you can check on hypotenuse leg. Okay, so let's look at these. Determine if I can use hypotenuse leg. If not, tell what else I would need to know. So here, first check is yes, these are right angles, because we could go through all the theorems to say if this is a right angle, then this has to be a right angle because a linear pair theorem right there. And then this is the hypotenuse. And then we could use the reflexive property to prove that a leg is congruent. So this one, yes, it works because of linear pair theorem, right angle congruence theorem, and reflexive property. So it would take a while to get there, but we could get there. And then B, yes, these are right angles, so that's good. We have that a leg is congruent, so that's good. But do we have any kind of information about the hypotenuse? No. So if I would need to know that the hypotenuse, hypotenuse, however you want to say that, is congruent. All right, see you tomorrow.